Hello, my name is Daniel, and today I will be walking you through the AMC 10A from the year 2002, and so let's get right into it. Problem 1. The ratio 10 to the 2000th power plus 10 to the 2002nd power over 10 to the 2001st power plus 10 to the 2001st power, 10 to the 2001st power is closest to each of the following numbers. So let's just divide the top and bottom by 10 to the 2000th power since that's way too big. So it's 1 plus 100 over 10 plus 10, right? So it's 101 over 20. So this is 5.05, I think, which is the closest to 5, so it's D. Problem number 2, given that A and B are non-zero real numbers, define A, B, C equals this thing. Find 2, 12, 9 for this one. We can just plug it in here. 2 over 12 plus 12 over 9 plus 9 over 2. This is 1 over 6 plus 4 over 3 plus 9 over 2, which is 1 over 6 plus 8 over 6 plus 27 over 6. So it's 27 plus 1 plus 8. This much is 36, so it's 36 over 6, which is equal to 6. So the answer is C. Problem 3. According to the standard convention for exponentiation, 2 squared squared squared, this equals to the 16th power, which is 65536. If the order in which the exponentiations are performed is changed, how many other values are possible? So for this one, you have to note that 2 squared squared, this one is the same regardless of how you perform the exponentiations. So this, which is 4 squared is 16, will be same as this first, which is 2 to the 4th power, which is also 16. So 2 squared squared, this is always the same value. So for this value, let's just write a figure here. 2 squared squared squared. This can be either be 2 squared 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 like this first, or 2 squared 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 this one first. So this can be 16 squared or 2 to the 16th power. So it says how many other values are possible. So other than this one, we have one more value, right? This is 16 squared, so we have one more value, it's B. Problem number 4, how many positive integers m is there at least one positive integer n so that mn is less than or equal to m plus n? Okay, so we're wanting to find n, right? So let's solve for n. N times m minus 1. This is less than or equal to m. So n has to be less than or equal to m over m minus 1, right? So m over m minus 1 will always be greater than m minus 1 over m minus 1, which is 1, right? So this value will always be greater than 1. So n can always be 1. So since there is a constant value of n, then there is always at least one positive integer n for any m, right? So there are infinitely many values of n, values of m. That means the answer is E, infinitely many. Problem number 5. Each of the small circles in the figure has radius 1. The innermost circle is tangent to the 6 circles that surround it, and each of those circles is tangent to the large circle and to small circle neighbors. Find the area of the shaded region. Okay, so if we see this, then it says that it has radius 1, right? So this would be 1, and then this whole thing, so the radius of the big circle, the outermost circle, this would be 3, right? And so the leftover area would be 3 squared pi, because that's the whole thing, right, minus 1 squared pi times 7, right, because there are 7 of these small circles that have to be subtracted. So this is 9 pi minus 7 pi, which is 2 pi. So find the area of the shaded region. The area of the shaded region is 2 pi, so the answer is C. Problem number 6. From a starting number, Cindy was supposed to subtract 3 and then divide by 9, but instead Cindy subtracted 9 and then divided by 3, getting 43. If the correct instructions were followed, what would the result be? Okay, so let's say that the starting number was x, then she had to subtract 3, so x minus 3, then divide by 9, but instead Cindy subtracted 9, then divided by 3, getting 43, so x minus 9 divided by 3 is 43. Then x minus 9 would have to be 43 times 3, which is 129. X equals 138. So if we want to get this, then then we can move this up here and then say that this equals 138 minus 3 over 9, which is 135 over 9, which is 9 times 1, 9, 5. It's 15, so the answer for problem number 6 is A. Problem number 7. A 45-degree arc of circle A is equal in length to a 30-degree arc of circle B. What is the ratio of circle A's area and circle B's area? We have this arc. This is the arc, and this should be 45 degrees of circle A is equal to a 30-degree arc of circle B. So it's saying that it's like this, 30 degrees. And this length is the same as this length, and yeah, this should be 30 degrees. What is the ratio of circle A's area and circle B's area? So if the radius of circle A is called A and the radius of circle B is called B, then this value, so the arc equals 45 degrees is 1/8 of the whole circumference, right? So it's 1/8 times 2a pi, and then this is also 30 degrees is 1 over 12, right? 1 over 12 times 2b pi, right? So 2a pi over 8 equals 2b pi over 12. So take out the 2 pi, and then take out this and make it into a 2, make it into a 3. So we would get A over 2 equals B over 3. 3A equals 2B. So what is the ratio of circle B's area and circle A's area and circle B's area? This can mean that A is equal to 2 and B is equal to 3. So ratio of the area ratio is always length ratio squared, right? So this would be A area to B area. This would be 2 squared plus 3 squared, 2 squared, 2 squared, 2, 3 squared, 2 squared to 3 squared. A should be here, B should be here, which is 4 to 9. So the answer is 4 to 9, and the ratio of circle A's area and circle B's area will be 4 over 9, which is A. Problem number 8. Betsy designed a flag using blue triangles, small white squares, and a red center square as shown. Let B be the total area of the blue triangles, let B the total area of the white triangles, and R the area of the red square. Which of the following is correct? So if you see here, you can see that there are like little grid lines, and just putting these grid lines here, these would be very helpful. Like this, like this, like this, and like this. Okay, so from here, we can see that in each sector, the area of the blue is equal to the area of the white. Here too, the area of the white is 2, the area of the blue is 2. Same here, same here, same here. So it's same for every square with the blue and a white, that the area of the blue is equal to the area of the white, right? So the total area of the blue triangle, so B, equals the total area of the white triangles, B equals W. So that's A. Problem number 9. There are 3 numbers A, B, and C such that 1001C minus 2002A equals 4004, and 1001B plus 3003A equals 5005. What's the average of A, B, and C? Let's just divide 1001 by everything. So let's just divide these by 1001. So C minus 2A equals 4, b plus 3a equals 5. So the average of a, b, and c. This is a plus b plus c over 3, and if you add these together, then we get a plus b plus c, right? So it's 4 plus 5 over 3, which is 9 over 3, which is 3. So it's B. Problem number 10. What is the sum of all the roots of 2x plus 3, x minus 4, plus 2x plus 3, x minus 6 equals 0? Okay, so this one we need to put the two equations together. 2x plus 3, and then these two have to be added. 2x minus 10. This is 0, so x equals minus 3 over 2, x equals 5, and so the sum of all the roots would be 5 minus 3 over 2 would be 7 over 2. So problem 10, the answer is A. Problem 11, Jamal wants to save 30 files onto disks, each with 1.44 megabytes of space. 3 of the files take up 0.8 megabytes each, 12 of the files take up 0.7 each, and the rest take up 0.4 megabytes each. It's not possible to split a file onto 2 different disks, or is the smallest number of disks needed to store all 30 files. So he wants to save 30 files. And the disks each have 1.44 megabytes. 3 of the files take up 0.8, so each has 1.44. But since these are all up to the 10th place, this additional 4 won't be much help. So we can just erase this 4, and it will be the same. So 3 of 0.8, and we have 12 of 0.7, and we have the rest, so 30 minus 12 minus 3, so it's 15 of 0.4 megabytes. So first we can see that 1.4 is twice the area, is twice the number of 0.7, so we could neatly put 2 of each onto 1 disk. So this would be 6 disks. So 6 we have here, and then what's left, we have 3 of the 0.8 and 15 of the 0.4. So if we count each 0.8 as 3, then just the area wise, this would be 6 times 0.4, right? So it would be like we had 6 plus 15 is 21, so 21 of 0.4s. And since each has 1.4, this would be the same as having 1.2 space. So this would be 7 disks. 7 disks for the disk for the 3 and 15. So our total answer would be 6 disks plus 7 disks, and we add them together, we get 13. The answer is 13. It's B. Problem number 12. Mr. Early Bird, yeah, we get the joke, leaves home every day at 8 a.m. to go to work. If he drives at an average speed of 40 miles per hour, he will be late by 3 minutes. If he drives at an average speed of 60 miles per hour, he will be early by 3 minutes. How many miles per hour does Mr. Bird need to drive to get to work exactly on time? Like, I don't think it will hurt to come early 3 minutes to work. But then the problem tells us to solve, so let's just solve. So he leaves at 8 a.m. This will be utilized in the last part of our problem. And yeah, so 40 miles per hour, it's late by 3 minutes. So 40 miles, so let's say that there are x miles, and x miles to work from home. So 40 miles per hour would be x miles times over 40, so x over 40 equals a certain number, a certain amount of time, a plus 3 minutes, right? So it's 1 over 20 hours. And 60 miles per hour would be early by 3 minutes, so x over 60 would be a minus 1 over 20. So if you subtract these two, then we would get x over 120, 3 minus 2, this equals 1 over, this equals 2 over 20 minus c plus 1 over 20. So 2 over 20, this is 1 over 10, so x equals 12. So there's 12 miles to get to work, and then we need to get to know the a. And so 12 over 40 equals a plus 1 over 20. And 12 over 40, this would be the same as 6 over 20, right? So a would be 5 over 20. So a would be 1 over 4. So he would need to drive 12 miles. So using this and this, he will need to drive 12 miles in 1/4 of an hour. So this is 48 miles per hour. So this would be B. And problem 13, given a triangle with side length 15, 20, and 25, find the triangle's smallest altitude. This is easy problem. There's a right triangle. Right triangle with side lengths 15, 20, and 25. As we all know, this is a 3 to 4 to 5 triangle. So the smallest so this would be a 90 degrees, and the smallest altitude would be the distance if we come from here to here, all straight and perpendicularly. So that means that since this triangle and this triangle is similar, this would also be a 3 to 4 to 5 triangle, so this would be 3, 4, 5. And then we can see that this is multiplied by 3, right? So here also 3 times 3, 4 times 3, which means that this side would be 12, this side would be 9. So the smallest altitude, this is this height, so altitude equals 12, so it's B. Problem number 14, both roots of the quadratic equation x squared minus 63x plus k equals 0 are prime numbers. So both roots are prime numbers, and if both roots are a and b, a plus b equals 63 and ab equals k. The number of possible values of k. Okay, so the only way that two prime numbers is sum could be an odd number is that 1 is 2. So the only way that this could happen is a equals 2 and b equals 61. And the question here is 61 a prime number? And 61 is a prime number, so this is the only way that's possible. So k can be only one value. So k can be only one value, 122. So it's one value. It's B. Problem number 15, using the digits 1, 2, 3, 4, 5, 6, 7, and 9 form four two-digit prime numbers using each digit only once. What is the sum of the 4 prime numbers? Okay, so two-digit prime numbers, that means that we have to use 2, 4, 6 in the tens digits, and in the ones digit we have to come either 1, 3, 5, 7, or 9. Oh yeah, but since it has to be a two-digit prime number, 5 also can't be in the ones digit, because any number with 5 in the ones digit, that's a two-digit number that will automatically be a multiple of 5. So it's 2, 4, 6, 5. And then it's a question of how we arrange the 1, 3, and 7, 9. Let's first try with the 2. Does 21 work? No, 21 is divisible by 3. 27 also doesn't work, but 23 works, and 29 works, so 3 and 9 is possible. 41 is possible. 43 is also possible. 47 is also possible, but 49 is not possible. 61 is possible. 63 is not possible. 67 is possible. And 69 is obviously not possible. 51 not possible. 53 possible. 57 not possible, and 59 is possible. So from here, we should be able to get a number. What is the sum of the 4 prime numbers? So the tens would be, so actually we didn't have to do this at all. So since they're only asking for the sum of the 4 prime numbers, somehow these will arrange themselves into 1, 3, 7, 9. These will somehow like arrange themselves accordingly, and they would get so their sum would be 2 plus 4 plus 6 plus 5, and then multiply by 10 since there's a 10th digit, plus 1 plus 3 plus 7 plus 9 equals 17 times 10 plus 20, which is 190. So the answer is E. 16, let A plus 1 is B plus 2 is C plus 3 is D plus 4 is A plus B plus C plus D plus 5. What is A plus B plus C plus D? So let's just add all these together. Then A plus B plus C plus D plus 1, 2, 3, 4, which is 10, equals 4 times A plus B plus C plus D plus 5, right? So A plus B plus C plus D plus 10 equals 4A plus B plus C plus D plus 20. So if 20 goes over here and A plus B plus C plus D goes over here, we will get 3A plus B plus C plus D equals minus 10. A plus B plus C plus D equals minus 10 over 3. So it's minus 10 over 3, it's B. Problem 17, Sarah pours 4 ounces of coffee into a cup that can hold 8 ounces. Then she pours 4 ounces of cream into a second cup that can also hold 8 ounces. She then pours half of the contents of the first cup into the second cup, completely mixes the contents of the second cup, and then pours half the contents of the second cup back into the first cup. What fraction of the contents in the first cup is cream? Okay, so let's draw this out. So she has 4 ounces of coffee. Then she pours 4 ounces of cream. She then pours half the contents of the first cup into the second cup. So there will be 6 ounces, and 1/3 would be coffee. 2/3 would be cream, and completely mix. And then pours half the contents of the second cup. So that would be 3 ounces back into the first cup. So from the first one, we have 2 ounces of coffee left, and then we get 3 more ounces of this mixture, and then 1/3 of it is coffee. So we would have 1 coffee. So we would have 1 part coffee, and 2 out of 3 is cream. So 2 ounces cream. What fraction of the content in the first cup is cream? So it's basically asking for this one. So it's 2 cream over the content of the first cup, raised with 1 plus 2 plus 2. So it's 5. So it's 2 over 5, which is D. Problem number 18. A 3 by 3 by 3 cube is made of 27 normal dice. Each dice opposite side sum to 7. What is the smallest possible sum of all the values visible on the 6 faces of the large cube? So there's a 3 by 3 by 3 cube. Let's make this a little lower. So this is shaped like the normal Rubik's Cube you see, because it is also a 3 by 3 cube. Like this, like this. Each dice opposite sides sum to 7. Yet, what's the smallest possible sum of all the values visible on the 6 faces of the large cube? Okay, so right here, in this cube, there are some cubes that have only 1 face visible. 1 face, and then for these to have the smallest possible sum, this would be 1, and then there would be 6 of these, right, in each face. So 1 times 6, and then there's the other portion that shows 2 faces, like this one or this one right here, and then 2 faces. That would have a 1 and a 2 to get the least possible sum. So 1 plus 2. 1 plus 2, and then times. So these are the number of edges, right? So this is 12. And then 3 faces. Yeah, and the parts that show 3 faces are these ones. So these ones will have 1, 2, and 3. So they will have 1 plus 2 plus 3, and then these are the number of corners, right? So times 8, and then this would equal 6, this would equal 3 times 12 is 36, this would equal 6 times 8 is 48. So this will be 42, 42 plus 48 is 90, so the answer is D. Okay, so let's go on to problem 19. Spot's doghouse has a regular hexagonal base that measures 1 yard on each side. He is tethered to a vertex with a 2-yard rope. What is the area in square yards of the region outside of the doghouse that Spot can reach? Okay, let's just say that it's this. It measures 1 yard on each side, and then he is tethered to a vertex. No, this is way too small. Let's make it a little bit bigger, like this. A little bit better. So he has this 2-yard rope, so he's tethered like this to here, and then he can roam around like this. So he can so the dog can reach this much, right? And then so he will be able to reach this much, plus this much, plus this much. So this would be 1, this would be 1, this whole thing will be 2. And this is 240 degrees. So so this region, so this region would be 2/3 of the whole circle, right? So 2/3 times 4 pi, and then these much would be 1/3 times pi, right? It's because this is 1/6 and 1/6, and so 2 1/6, they're together, it becomes 1/3. And so 1/3 pi becomes 1/3 pi, and then this is 8/3 pi, and so when they're together it's 9/3 pi, which is 3 pi. And so problem 19, the answer would be E. Problem number 20, A, B, C, D, E, F lie in that order on AF, dividing into 5 segments, each of length 1. Point G is not on line AF. Point H lies on GD, J lies on GF. The line segments H, C, J, E, and AG are parallel. Find HC over JE. Okay, so let's find this point, and then there's A, B, C, D, E, F. Yeah, so let's erase this much, and then we would have point G, and then let's say this would be point G, then it would be like this, or like this, and like this. Okay, so this would be A, B, C, D, E, F, and this would be G. Let's enlarge the picture a little bit. Make it a bit bigger, and then the line segments HC, JE, and AG are parallel. So if we find point H lies on GD, so HC would be from here to here, and then JE would be like this. And it says that these three are parallel, so HC over JE, this is H and this is J, right? And so since this triangle GAD is similar to this triangle HCD, then, and the ratios are 3 to 1, right? So 3 to 1 ratio. So that must mean if the length of GA is x, then HC must be 1/3 x. And similarly with JEF, so this triangle GAF, similar to this triangle JEF, and then the length would be 5 to 1, right? 5 to 1. So JE would be, this is x, so 1 over 5x, right? So HC over JE is this over this, so it's 1/3 x over 1/5 x, which is 5 over 3. So it's D. Problem number 22. A set of tiles numbered 1 through 100 is modified repeatedly by the following operation. Remove all tiles numbered with a perfect square and renumber the remaining tiles consecutively starting with 1. How many times must the operation be performed to reduce the number of tiles in the set to 1? Okay, so first let's do a couple of the primary ones. So let's just go through the motions, and then we'll maybe find a pattern, right? So numbers 1 through 100. So there are 100 numbers, and then remove all tiles numbered with a perfect square. So the number of perfect squares in 1 to 100. There are 10 perfect squares, right? And so minus 10, it becomes 90. And then from 1 to 90, the number of perfect squares is 9. So if we subtract 9, that becomes 81. If we subtract 9 from here, since there are 9 perfect squares in 81, it becomes 72. And then since there are 8 perfect squares in 72, we get 64. And so from here we can notice that there's the same number, because this is also 8 for 56, and so there's the same number twice, and then these are all perfect squares, right? So the perfect squares keep occurring, right? So how many times must the operation be performed to reduce the number of tiles in the set to 1? So the final thing would be 1, and so to make this 1, this would have to be 2, and then since this is 2, the one above it must be 4, so this must be 2, and then the one above it must have been 6, so this would have been 2. And so we can see that this pairing of sorts, this goes on until the 2's. So there are so this 1 time, 2 times, 3 times, 4 times, 5 times, and so this and so if we count the number here, then there's 1 to 10, there's 2 plus 2 times 2 to 9, so 1 to 8, right? Because that's just the number of things. This is 2 plus 2 times, this is not 1 to 8, this is just plain 8, since there are 8 numbers from 2 to 9. 2 plus 16, which is 18. So number 22, the answer is 18. The answer is C. Problem number 23, points A, B, and C, D lie on a line in that order with AB equals CD and BC equals 12. Point E is not on the line and BE equals CE equals 10. The perimeter of AED is twice the perimeter of BEC. Find AB. So ABCD lie on a line. Yeah, so this is a line, and then with AB equals CD and BC equals 12. So this would be A, and then this would be D, and then AB equals CD, right? AB equals CD, and then BC is 12. Point E is not on the line, and BE equals CE equals 10. So if BE equals CE, then it must be on the midpoint of B and C. And so if we put lines, this would be an isosceles triangle, and then this would also be an isosceles triangle, triangle AED, since this is E, because these two are the same length apart, and then since this is isosceles, these two also must be isosceles. And so since BE equals CE equals 10, if we split this into half, then 12 also splits into half, so it becomes 6 and 6, and so it becomes apparent that this is a 5 to 4 to 3 triangle, so this becomes 8. And so we have to find AB, right? So we have to find this distance. So let's use this one here. The perimeter of AED is twice the perimeter of BEC. So oops. At least, yes. Okay, so the perimeter of AED is twice the perimeter of BEC, right? So if this is A, and this is B, this is B, this is A, and so the perimeter of AED would be 2A plus 2B plus 12, and then this is twice the perimeter of BEC, right? This is 2 times 6 plus 6 plus 10 plus 10, so it's 16 times 2. So A plus B plus 2, A plus B plus 6 equals 32. A plus B equals 26. And so if you find AB, so first we have got that AB equals A plus B is 26, and then using the Pythagorean theorem on this one, B squared equals A plus 6 squared plus 8 squared, so B squared equals A squared plus 6 plus 12A plus 36 plus 64, so B squared equals A squared plus 12A plus 100. And since A plus B equals 26, we can say that B is 26 minus A. So if we put 26 minus A into B, then we can say 26 minus A squared equals A squared plus 12A plus 100. So A squared minus 52A plus 26 squared. What's 26 squared? 36, 156, 1, 2, 2, 2, 4, 5, 676. 676 equals A squared plus 12A plus 100. And so, take out the A squared, move the 52A here, then it would be 64A equals 576. So A equals 576 over 64, which is 4960. 36, 54, yes. So this is 9, so A would be 9. The answer is D. Problem number 24, Tina randomly selects 2 distinct numbers from the set 1, 2, 3, 4, 5, and Sergio randomly selects a number from the set 1 to 10. What's the probability that Sergio's number is larger than the sum of the 2 numbers chosen by Tina? Okay, so Tina would select 2 numbers from 1, 2, 3, 4, 5, and Sergio's would select 2 numbers from 1, 2, 3, 4, all the way to 10. So Sergio could have 2 probabilities. One, he could select 1 number from 1 to 5, or he could select 1 from 6 to 10. Both of these probabilities have 1/2 probability, and if he happens to get 1 from 6 to 10, then this would be 100% larger than the sum of, so Tina randomly selects 2 distinct numbers from the set. Okay, so Tina can select, let's just put out everything. There's only 10 possibilities, so there's 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. That is 10 correct, and then if we sum these, this would be 3, 4, 5, 6, 5, 6, 7, 7, 8, 9. And so if we put them in order, then we have 3, 4, and then 5, 5, and then 6, 6, and then 7, 7, and 8, and a 9. Okay, so what's the probability that Sergio's number is larger than the sum of the two numbers chosen by Tina? So Tina selecting any one of these, she has a 1 over 10 chance. And then Sergio selecting. So if Tina gets a 3, then Sergio needs to get anything above 3, right? So it will be 4 to 10. So that will be 7 over 10. Getting a 4, that will be to get something greater than 4, he will need to get 6 over 10. And for these two 5s, he would need to get and for these two 5s, he would need 5 over 10. For these two, 4 over 10. For these two, 3 over 10. For 8, 2 over 10. And for a 9, a 1 over 10. So the probability that Sergio's number is larger than the sum of the two numbers, so this is 1 out of 10 multiplied by this plus this plus these times 2 plus this times 2 plus this times 2, because there are two numbers each, see, and then this plus this, so the whole thing equals 1 over 10 multiplied by over 10, and then 7 plus 6 plus 5 times 2 is 10 plus 4 times 2 is 8 plus 3 times 2 is 6 plus 2 plus 1, which is all under 100. And 7 plus 6, so it's 13 plus 18 plus 6 plus 2 plus 1 plus 9. So this is 100, and then 13 plus 18 plus 9, this would be 230, 40. So this would be 40 over 100, which is same as 2 over 5. And so the answer is A. And the last problem, in trapezoid ABCD with bases AB and CD, we have AB equals 52, BC equals 12, CD equals 39, and DA equals 5. Diagram not to scale. So the area of ABCD, so that's what we want. Okay, so we find that peculiarly, if we move the A to C, point C, and then make these two parallel, then this would be 5, and then since this much is 39, this would be 13. So it turns out that this angle is actually a right angle. Oh, that's why this is diagram not to scale. So anyways, we discover that this triangle is a right triangle, and actually I think that we can just put like a bunch of like right triangles here, and then it would solve the problem. So let's see, 39 is 3 times 13, right? And then 52, is 52 divisible by 13? Yes, 52 is 4 times 13, which means that they must have like they must have 3 13s here and the 4 13s down here, and then this would perfectly connect to make amazing. So this would be 5, this would be 12. Let's put this in a different color. 5 12 5 12 5 12 5 12, and these would all be 13 13 13 13 13 13 and 13. And so the thing is that these will be right angles. These will be right angles, 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 and these will be right angles. So we have 7 triangles with area, so its area is 5 times 12 times 1/2, which is 30, with area 30, right? So this is 210. So the answer is C, and that was problem number 25, and thank you for watching.